Okay, this is the study group for the digestive system and endocrine system. We're starting with the lab for chapter 23. The first question is list the 4 functions of the digestive system. And
you want us to participate, or you're going to go ahead and say everything?
oh, I don't have all the answers. So, like, if you guys know the answers and stuff, like, feel free to jump in.
Okay, I would say for that, the 4 functions are ingest the food, digest it, and you have 2 types of digestive food, which is mechanical and chemical.
Mm-hmm.
And absorption, the nutrients, and secrete the waste.
Elimination, yeah. I guess secretion's the same thing.
Yeah, elimination, correct.
Okay. The next question is compare and contrast mechanical digestion and chemical digestion.
Well, mechanical is mostly like chewing and stuff like that. The chemical one is breaking down all the enzymes and proteins. Like the stomach acid is involved in that. Saliva and what else was it?
Actually, Ms. Baker gave this example where she said the emulsification is not actually a chemical, it's not a part of chemical digestion because no new compounds are being formed.
Yeah.
It's just the same stuff, but they're like kind of, on some level, they're physically separating the fats down to smaller pieces. So then the chemical digestion can happen afterwards. So you have to be careful. You need to like look for a new compound being created, I think.
Is the emulsification happening in the mouth or when we're chewing the saliva?
No, it happens later.
One more time again. Can you repeat that? No. Can you repeat that?
Okay. Well, mechanical digestion, like it. I think we all understand that it's, you know, chewing and anything that involves like physical force and all that. But Ms. Baker kind of gave us a trick question. I think she was trying to make the point that emulsification, which is where pretty much if you've got fat and you eat it, like the fat sticks together because fat and water, like they don't go together. They'll always separate. So emulsification, the bile goes in there, and it like breaks down the fat into like thousands and thousands and thousands of tiny little bits that the chemical digestion can then go in and attack. Otherwise, it would just have this large fat globule to try and attack, and it couldn't. So she said because there's no like there's no new chemical processes actually happening in that, it's still considered mechanical. So it seems that with chemical digestion, we need to be very careful and make sure that like a new compound is actually being created.
All right.
List the 4 layers of the digestive tract.
Okay. 4 layers up here. Noah, you're there?
Well, the
4
4
layers
yeah.
is the mucosa layer, submucosa layer, mucosa layer, and serosa layer.
Yep. List the secretions and enzyme produced by the salivary glands. So that, I think, it has to do with the chart that we got. Okay, so the salivary glands produce the salivary enzyme malase by talin, and this enzyme begins carbohydrate digestion to disaccharides. So your saliva can actually begin breaking down carbs, I guess.
Is that the
I
enzyme? Because that's
amylase?
yeah, amylase or
Yeah,
whatever.
that's the enzyme. I'm trying to see if that's
Okay.
the answer, though.
I can't see your face. I know it's okay. Where did you put everything?
I think that's it.
Okay.
Um, I'm sorry, what?
What is the next question?
It is list the functions of the pharynx, epiglottis, and the esophagus.
What are the functions?
Mm-hmm.
Function, you got it? Function of the stomach. It regulates the rate of gastric emptying.
And secretes the gastric juice of HCl, hydrochlorine, right? And
HCl?
hormones. Yeah, there you go, HCl.
No, is it HCl or HCH?
Hormones and the intrinsic factor. And
Yes.
it's,
Okay, so it's HCl?
yes.
No, HCI. It's not O, it's I. HCI.
Okay, HCI. Okay, so the pharynx is throat. We didn't go over. What does the epiglottis do? It
prevents us from choking when you swallowing the food.
okay, so what it does then it's got that skin, that flap of skin that it uses to cover on top of the trachea so that food can't go down the trachea?
Right.
Okay. Okay, and I think we already said the esophagus is a long tube that connects the pharynx to the stomach, and it's got those two sphincters. Okay, list the functions of the stomach and describe its main regions.
The main what?
Regions.
Regions?
Yeah, functions of the stomach and main regions.
Okay.
So the three parts of the stomach are the fundus, body, and pylorus. As far as functions go, it functions in digestion. Its most important role is to regulate the rate at which chyme is delivered to the small intestine. List the main regions of the small intestines, entera, in order and what occurs in each area. Oh Lord, okay.
What does it mean by their region though? Like where, like the quadrants, you mean?
The small intestine?
Is that what it's referring to though?
Well, I think what they really want to hear is the duodenum, the jejunum, and the ileum.
Right.
Oh.
That's it. What
Duodenum is the first one.
I'm trying to see if there's a picture of it here.
Also, it says the secrete hormone and digestive enzyme. She says also the duodenum is where the most absorption occurs.
Mm-hmm.
Right?
That's correct. Let me go back to... Okay. she emphasized for the small intestine to remember DJI, Dow Jones Industries, duodenum, jejunum, ileum. The duodenum, they said in the lecture, the length is 12 fingers. Most absorption takes place here. You already said that, but like she emphasized it. It gets chyme from the stomach. It's an accessory gland, secretion delivery from liver, gallbladder, and pancreas. The jejunum is the second part. It's a segment of the small intestine. It's 8 foot long. Some absorption takes place here. The ileum is 12 feet from jejunum to ileocecal valve, and it protects from reflux. There's this was a question on that little quiz that she gave us. There's numerous patches of lymphoid tissue called Peyer's patches here in the ileum.
Okay.
Okay, and I think we just covered that question. Okay, what is CCK and what does it stimulate when released from the duodenum?
I can't find that.
Well, I remember it in relation to the gallbladder. CCK. What is CCK?
Right here. It is the fat. It is the fat. It says it is the fat in the duodenum stimulates and releases of the hormone cholecystokinine. That's what it is. Oh my God.
Well, that's the gallbladder. That's what I was reading. The gallbladder contracts and releases bile in response to the hormone cholecystokinine, CCK. But it's asking about the duodenum. Guys, could you? I'm gonna look up CCK for a second.
All right.
Briefly describe how and where absorption of nutrients occurs. You guys all know that, right?
Underneath that, at the bottom says what it crosses. You see that? The bottom point, Sarah.
I see. The fat in the duodenum stimulates the release of a hormone.
Right.
Mm-hmm. Okay. Yeah. Let me just read it out. The fat in the duodenum stimulates the release of a hormone, cholecystokinin, CCK. This hormone enters the bloodstream and circulates back to the gallbladder, where it causes the smooth muscle of the gallbladder to contract. And then, going back to what it says in the outline, when the gallbladder contracts, the bile is ejected into the cystic duct and then into the common bile duct and duodenum. Okay. Okay, so relates back to fat. Fat gets there, then there's going to be CCK. Gallbladder reacts to that hormone and produces bile because of it. That's the short of it. Cool. Briefly describe how and where absorption of nutrients occurs. The answer is the duodenum. List and describe the structure and function of the large intestines, colon. List the three main areas of the colon in order.
All right, there's 4 functions. Absorption of water and electrolytes, synthesis of vitamins, temporary storage side of waste, and elimination of waste from the body are the 4 functions.
Okay. Cool. I think you covered it.
Oh.
Define defecation, diarrhea, and constipation, and how peristalsis and absorption are affected by each condition.
Well, as the waste moves through, I guess water is absorbed from the feces,
Mm-hmm.
and trying to figure out. So that way it solidifies so that it can be passed through the rectum in a more solid state.
What is going on with diarrhea?
Probably not enough water reabsorption. My guess.
But why?
Well, sometimes the virus, like sickness.
She mentioned
Bacterial, I guess, infection.
I think she mentioned over there if you have E. coli, that you might die and you may have diarrhea and all that stuff for that bacteria. Didn't she?
No, but E.
Okay,
coli
well,
in our intestines
yeah.
normally.
Yeah, it's part of our normal flora. What she was saying is if, like, we defecate and somehow that bacteria is out there because it was in our stomach to begin with, if somehow we reintroduce it back into us into places it's not supposed to be, then we can get sick because our body's not designed to handle it in that place. But yeah, what is, from like a mechanical standpoint, what's going on with diarrhea?
Let me see.
Oh, here we go. I think here's the whole answer. Peristalsis and absorption. Intermittent and well-spaced peristaltic waves move the fecal matter from the cecum through the colon. By the way, I got corrected on that today. It's pronounced cecum. As the fecal matter moves through the colon, water is continuously reabsorbed from the feces across the intestinal wall into the capillaries. Consequently, as the feces enter the rectum, it is changed from a watery consistency to a semi-solid mass. What you said already. Feces that remain in the large intestine for an extended period lose excess water, and the person experiences constipation. Okay, so it's staying in there too long, and the absorption just keeps on happening. Rapid movement, because the person's sick, through the intestine allows insufficient time for water reabsorption, so hence the diarrhea. Okay. Cool. Okay, that makes sense. So, constipation. Do you think we need to know about drugs that are administered to fix it?
To fix diarrhea or
What types of
constipation?
drugs?
Yeah, both of it. Because it's actually acting on the peristalsis. Like if somebody's having diarrhea, they give them a drug to slow the peristalsis down. so that there's not a lot of pressure to move stuff out. But if somebody's constipated, they give them a drug to do the opposite and try and move it out.
A laxative.
Yep. They're either trying to decrease or increase motility here. Well, in any case, I think that's the answer.
When we just learned about immunity or whatever, and the fever is the process where the body's trying to fight, and
Yeah.
then the diarrhea. So, like, at what point we're supposed to let the diarrhea happen before we take those drugs to stop it?
I think
Or
this
to a
is
certain
probably
point?
I think this is probably more than we need to think about now, but I would think
Okay.
that you would kind of, from a practical standpoint, if somebody's having diarrhea, you don't want them to be dehydrated and sick. Like, you want somebody to be drinking their Gatorade and stuff if they're sick, because they might also be having other problems, like vomiting, sweating like crazy. They're losing fluid anyways. You don't want them to be losing more. But I don't really know yet.
Yeah, just a thought. I was just wondering.
That's... Yeah, I get what you're saying, though.
All right, next
List and
question.
list and describe structure of the liver, gallbladder, and pancreas, and include their functions and their secretions. Oh God.
Well, the liver's in the right upper quadrant,
Mm-hmm.
and
What was the other organ?
The liver, gallbladder, and pancreas. They're not actually asking where it is anymore. They just want to know what they do.
Oh, okay. Well, the pancreas, doesn't it secrete like the
Location.
certain hormones as well?
The pancreas secretes.
Yeah.
Hold on, I knew this. It secretes
the liver
amylase,
bile.
lipase, and protease. Also trypsin and chymotrypsin.
Okay.
So that's all to digest those sugars, fats, and proteins in that order.
Okay.
Back to bed.
But let's see. So
Sarah, can you tell me what page you are on the book?
no, because I have a different book than you.
Oh.
I'm actually looking up the liver right now to see what the book describes the function is. And I get, to be honest, I get confused with the chyme. Because it's easy remembering the gallbladder. It's there to secrete the bile and the bile salts.
Is the liver there to filtrate also?
I'm sorry, what?
Is liver one of the functions to what was it called? Filtrate?
Yes.
Sarah, on page 443, is that you don't have the same book as we do?
No, I have an older book. I have the same one that Miss Baker does.
Okay. It lists 9 functions.
Yeah, it's okay. Do you want to read them out? I think we're on the same page.
Yeah. It says the liver is essential for life and performs many vital functions. First one is synthesis.
Oh, Lily,
bile
I'm sorry. I'm
salts.
going to mute you. You can unmute yourself. Okay, go ahead.
The first one is synthesis of bile salts and secretion of bile. The second one is synthesis of plasma proteins. The third one is storage. The fourth is detoxification. The next one is excretion. The next one is metabolism of carbohydrates, metabolism of proteins, metabolism of fats, and phagocytosis. And so you must have that in your book too, just somewhere.
Oh yeah, it's just page 430 for me. They didn't change the text or the pictures or anything. They just rearrange the blocks of text. Okay.
So there's a little bit more in-depth, but basically that's what those the functions are.
And I gather it's important for us to remember for storage ADEC for the vitamins that it stores, A, D, E, and K.
Right.
And vitamin B12 too. The gallbladder is underneath the liver. The cystic duct connects the gallbladder with the common bile duct.
Right.
The liver produces the bile, but it's the gallbladder that stores it.
And that's pretty much its only function is to store the bile.
Yeah. And pancreas is right underneath the stomach. The head of the pancreas is on top of the duodenum. And the pancreatic duct carries digestive enzymes from the pancreas to the duodenum. Oh, here we go. Here's the thing we need to remember about the pancreas. The pancreatic enzymes are the most important of all the digestive enzymes. So the liver does a bunch of stuff. Most absorption takes place in the duodenum. And the pancreatic enzymes are the most important of all the digestive enzymes.
Right. That's even italicized.
Okay. Let's see. Locate and label in the diagram of the digestive system the following organs or structures. These are all things that are on our picture packets. So we really just need to go through there and point them all out.
All right.
Let's see. List the pathway of food from the mouth to the anus, listing all the main organs through which food passes. There's a sum it up actually that I think does this pretty well.
Yeah.
Okay. Oh, okay. Have you guys read the sum it up for the turkey dinner?
I did it. Yeah, I did. I read it.
I think that's got all the answers.
Okay.
Lily, you got your hands full. Do you want to read it or me?
Go ahead.
Okay. How is a turkey dinner digested and absorbed? 1. In the mouth, food is chewed into tiny pieces and mixed with saliva. 2. The smaller pieces of food are transported through the esophagus to the stomach, where they are mixed, mashed, and churned into chyme. 3. The partially digested food, chyme, squirts into the duodenum, where it mixes with bile and the pancreatic and intestinal enzymes. Pancreatic amylase and the disaccharides digest the polysaccharides to monosaccharides. The pancreatic proteases, trypsin and chymotrypsin, and the intestinal proteases digest the proteins to amino acids. Pendulum-like peristaltic motion washes the digestive food across each villus, those little fibers, thereby enhancing absorption. The simple sugars and the amino acids are absorbed into the blood capillaries of the villi. These capillaries eventually empty into the portal vein for transport to the liver. Bile emulsifies the fats, and pancreatic and intestinal lipases digest them. The end products of fat digestion are fatty acids and glycerol. The fat products are absorbed into the lacteals of the villi. Most of the digestion and absorption occurs in the duodenum, the meeting point for digestion. The unabsorbed food material moves along the jejunum and ileum and into the large intestine. A large volume of water and certain electrolytes are absorbed along this route and a semi-solid stool is formed. The presence of the fecal matter in the rectum gives rise to an urge to defecate. Oh, and Miss Baker emphasized that it's like the actual stretching that makes you want to go to the bathroom.
Yeah.
So,
Well, that's good because it lists the path and the organs, and then
yeah.
goes into detail about what happened.
Yeah, I really like this summary. I'm thinking about maybe like scanning it and printing it out again and just like highlighting all the organs in there in the terms.
That's a good idea.
Because it's even got like the amylase, like an example of what it does.
Okay.
What nutrients are absorbed after the breakdown of carbohydrates, CHO, fats, and proteins?
Right. Fats and proteins. Right.
Okay, so it seems like carbohydrates, you get the starches and sugars. With the proteins, you want to get the amino acids. And with the fats, you want to get the triglycerides. Which are
With the fat,
glycerol.
you're gonna get the lipids.
I'm sorry, what?
With the fat is the lipids, right?
Oh, yeah, they're lipids. But lipids are another word for fat. Like
Yeah.
carbohydrates are another word for
Sugar.
yeah. But the actual fats that the reason why the nutrients in them that you want to get, it seems, are triglycerides, and within them the glycerol and fatty acids. Let's see.
So,
Do you think we need to know that table 23 too? For the vitamins?
The vitamin?
Yeah.
probably just the A deck.
Yeah. Okay.
I mean,
Okay, guys.
because I take vitamins, I kind of know some of this, but
Oh, are you a nutritionist?
no, when I take vitamins, so I know why I take them.
Oh,
So,
okay.
I mean,
Fair enough.
I take B vitamins and for certain reasons, and I take vitamin D for a reason.
I got pregnant and they told me to take some vitamins, so I did it, and that was about it.
Really?
The rest of the time it was just like straight Mountain Dew, nothing but. Just kidding. I'm kidding.
That's why you need the vitamins. For that
It's like
reason.
I'm kidding, but I'm not kidding. God. Okay, endocrine system. What is a gland?
Let me get back over there. That chapter 7, what is that?
Chapter 14.
14? 14.
There's two things we need to know about glands. And now remember this for the rest of my life, because I was corrected publicly.
What?
Glands, we need to know that they secrete chemical substances called hormones. That is the definition of a gland, like flat out. That's what a gland is. But for the endocrine ones, we also need to know on top of that that they don't have any ducts. They're ductless.
Right.
What's a hormone?
Chemical messenger.
And what is it?
It
What's it
tells
do?
it tells certain organs to do something like your pituitary gland
Hmm.
has like two hormones. Like when you have for your menstrual cycle, for instance, it sends out a hormone that prepares the uterus with the lining and prepares like to get pregnant. And then after a certain point, then it sends out another hormone that signals the ovaries to release the egg. And then if pregnancy doesn't happen, then you have your period, and it tells the uterus to shed the lining.
Oh my God, was that an example in the book? Because I read this to myself and I completely.
That's just a personal example that I know.
Oh, oh, okay. No, it's a good example. No, I was just kind of like, how late was that?
No.
Okay. No, perfect, cool. What's a receptor?
Jelly.
They they're hormone receptors.
I'm sorry, I'm gonna mute you, Lily. You can unmute yourself. Oh,
Hormone receptors.
I'm sorry, what?
Are you talking about hormone receptors?
Yeah,
Or
yeah, it just says receptors in the lab, but yeah, hormone receptors.
um, they bind to receptor sites of the cells of their target tissues.
Mm-hmm.
There's two types. Those located on the outer surface of the cell membrane, which are membrane receptors, and those located within the cell, which are intracellular receptors. And the hormones recognize their target tissues because it's like a lock and key. Like the hormone and its receptor can be compared to a lock and key. The key must fit the lock. So when it gets sent out, it knows where it's going.
Cool. Perfect. Okay. Um, oh, negative feedback loop or negative feedback system.
What it is?
Yeah.
Okay.
Oh, it's on page 262, guys.
250 what?
262.
Oh, 260.
And it is on page 254 if you decide to be a chick. Never mind, I'm not going to swear. Um, so essentially what I get from a negative feedback loop is um, the pituitary gland tells it, hey, less of this hormone. So there's going to be less. And then well, actually, it's got an example here. The pituitary gland says less of this, so it sends out less cortisol to the adrenal cortex. And then after that,
Isn't this what Miss Baker was emphasizing about with the analogy of the air conditioning
yeah,
as a constant thing?
yeah, it's
Is that what
there's
this
this
is?
your pituitary gland has a set point of how much it wants of something to accomplish its goal. So if it thinks that there's too much or it's getting too much past the set point for the thing, it says less of it, and then it travels back and goes, okay, I did less, and it goes, but here's how much I still have down there. And it goes, oh, that's still too much, so less of it, and it keeps on going less, less, less until it gets the information back that it's at the set point that it wants.
Okay.
That's how I understand it. You already got target tissue. Compare and contrast endocrine and exocrine glands.
Lily, I thought you just had one child.
Did she go over exocrine glands?
I don't know, I can't find it.
I thought that was kind of odd. Well, okay. I'm just going to look that up really quick then, so I can just get the answer.
Oh,
Okay. Um, okay. Can you guys see what's going on here?
we're trying to find the difference between endocrine and exocrine, right?
Yeah.
Okay. I'm having trouble finding the exocrine.
Okay. But I think I might have the answer here.
Okay.
Can you see my screen?
Yeah.
Okay. It looks like Miss Baker did say very briefly that endocrine, endo means in, so they stay in the body endo. I don't remember anything in that lecture about exocrine except for outside, but it's got examples here of mucus, saliva, digestive secretions, sweat, tears. I guess anything that can get out of your body. Anything that ultimately exits the body. Okay, and all of the endocrine things always stay inside the body. Okay.
All right.
Okay. Label a diagram with endocrine glands. The hormones secreted by each, along with the function of those hormones. Didn't she say that there was a table we had to memorize for this too? Oh yeah, table 14.1. Okay, so this wasn't in our picture packet, but you know figure 14.4?
I'm
Yes.
sorry.
Yeah. This has all the glands and what they're supposed to do and the hormones that they're pumping out.
Oh, yeah. Okay.
It's only got the abbreviations, but so I guess if we just study that and study the table along with it, we'll get it. List the area of the brain that controls the pituitary gland.
I forgot.
It's attached to the undersurface of the hypothalamus.
But it's not part of the hypothalamus?
Oh, okay. The secretion of the anterior pituitary gland is controlled by the hypothalamus. Cool. Although it is a part of the brain, the hypothalamus secretes several hormones and is therefore considered to be an endocrine gland as well. Okay, so, yep, hypothalamus is the answer.
Okay.
List the two areas of the pituitary, hypophysis, and the difference between them. So that would be...
One is the anterior, right?
Yeah. So it's the anterior and the posterior pituitary gland?
I don't see anything.
What was the question again?
List the two areas of the pituitary, hypophysis, and the difference between them.
Yes, anterior and posterior. Two main parts.
Okay.
What's the differences between them?
It says the secretion of the anterior pituitary gland is controlled by the hypothalamus.
Okay.
What about the
I don't really see a difference in it, other than, I guess, the location of it.
Well, it seems like the function is different, location and function. So, as far as I can tell, the anterior pituitary gland is... Okay, it's underneath the hypothalamus, and it secretes 6 big hormones that control other glands, and which in turn affect like loads of organ systems. Meanwhile, it seems like this posterior one is actually an extension of the hypothalamus. It's like still technically the brain. It's composed of nervous tissue. That's why it's called the neurophysis, and it only produces 2 hormones. And these 2 hormones are an antidiuretic hormone and oxytocin. Okay.
And where is that? Is that on? Oh, but you have a different book, right?
Yeah. You know what? It's near the table 14.1 for me. It's probably really close around that area for you. It pretty much just says the pituitary gland. It'll say pituitary gland and hypothalamus. Then it's got a write-up on the anterior. You flip like 1 or 2 pages, and it's got the posterior. And it'll say like right at the beginning what the location is. Then it'll say what the function is, and then it'll go into like greater detail again.
Okay. Thank you.
List the hormone produced by the kidneys that stimulate the red bone marrow to produce RBCs. Erythropoiesis. Oh my God, how do you say this? Erythropoiesis. There we go. Oh my God. I'm having trouble remembering red bone marrow. But it would make sense that blood cells would be created by a hormone. You guys have any luck?
What are you looking for?
I'm looking for the hormone produced by the kidneys that stimulates the red bone marrow to produce red blood cells.
I thought you just said it was the. Shoot, you just had that too.
No, I'm not that smart.
You just had that. Hold on.
Yeah, I was just saying I didn't remember it in the lecture, although when I think it through, it makes sense that it would be a hormone.
Con mi pizza. Ah, pues ¿dónde le come entonces?
It's erythropoietin.
Ooh, what is it?
Erythropoietin, which is the hormone secreted by the kidneys that stimulate the bone marrow to produce red blood cells.
Cool, where'd you find that?
Well, I kind of remembered but so I just looked it up.
Oh, you looked it up online?
I'm sorry?
Did you look it up online?
No, I looked it up in the back of the book. I remember that because the what is it that sends the signal to the kidneys to make it when you're fetal erythropoiesis or something like that?
Oh, FSH? Are you talking about that?
The thymus gland sends
Okay.
in the fetal. It sends the hormone or something, the message to the kidney to produce that.
Okay.
And then, remember, then it's not very active after we grow up.
Oh, okay, wow. I was reaching back into the dawn of time. Oh, God.
That's what I thought you said that when you said that. But
No, I was really having trouble with this.
erythropoiesis is the process, but I couldn't remember the name of the hormone.
And what's the name again?
Erythropoietin, Poietin.
Okay. I'm still trying to figure out where the hell that is in the book.
It's what we just studied about the thymus gland, oh my gosh. The test that I just didn't do good on. The lymphatic system.
Oh yeah, I was hoping it was in this chapter.
No, but I mean that's how I remembered it.
Gotcha. Well, okay. I'm gonna have to look over this chapter again. It feels weird that it wouldn't be in here. Okay, anyways, next one. List the hormones secreted from the right atrium of the heart to decrease blood volume.
I'm sorry?
Okay. List the hormones secreted from the right atrium of the heart to decrease blood volume.
Does the gland stimulate the signal to the heart to do that? The hormone secreted
the
from
gland.
what?
It seems like the heart would I don't know if the heart would put out the signal. I know it's the gland that puts out the hormone.
Right. That's what I'm wondering.
Hmm. Hmm.
Hmm.
You guys, I'm sorry, I have to go. I have to
Oh,
put my dog to sleep.
no, that's cool. I understand. Um,
Yeah.
Bye,
Okay.
Lily.
um,
Guys.
good
Bye,
night.
guys. Good night.
No, I've been there. Um,
Is it just me and you?
yep.
Oh, okay. Well, Jocelyn was in and out. I thought she was in, but
I don't care. I'm finishing this damn lap.
a decrease in blood volume. We're almost finished. What
Yeah.
is happening?
Yeah.
Decrease in blood volume. What is that? Nothing.
Like I remember blood calcium. Hmm. In theory, it should be on the table in 14.1.
I was looking there to see if it mentioned that, and I couldn't
Oh,
see anything right up. You can look, but because my eyes might be. Blood volume.
hmm. Um, no, I don't see it. Hmm. Okay. Let's see what Google says. Keeps on. It sounds like it's the ANF hormone, but it's not ringing any bells with me.
Oh, I'm still looking.
Hmm.
I'm not seeing anything.
Yeah. Well, I'm gonna make a note and just ask tomorrow. Ask Tuesday about this.
Okay.
Explain the function. I'm sorry. What?
I just saw. Well, I don't know if this is it.
Ooh.
Under adrenal medulla, one of the. I don't know if this is right though. It says one of the epinephrine, which is classified as a catecholamine, help the body respond to stress by causing the following effects. And the last one says changing blood flow patterns, causing dilation of the blood vessels to the heart and muscles and constriction
Ooh.
of the blood vessels. Could that be something like that? It's
Um,
saying
yeah.
decreased blood volume. So if you alter the cause dilation of the blood vessels to the heart and muscles, constriction of the blood vessels to the digestive tract, though. That's why I didn't know. It doesn't say anything about the right atrium, but that's the one that pumps, right?
Yeah. Um,
That's the closest thing I can find.
mm,
Do you see that section, the adrenal
yeah.
medulla, under
Yeah,
adrenal?
it's page 263 for me.
Mhm.
Um, I think this is the answer. It's just I'm not sure if they want us to put down epinephrine and norepinephrine or
It's part of that. Yeah,
catecholamines.
yeah, whatever that is. That's what
Mm.
I think it is. But that's part of the sympathetic response. Where,
Oh, to decrease, yeah.
yeah, I'm just gonna put that.
No, sympathetic would be to jack it up.
Well,
Parasympathetic would be to calm it down.
it says. Oh, it says when stress activates the sympathetic fight or flight response, the medullary cells stimulate the cortex to secrete steroids, also stress hormones. Um,
Okay, let's ask on Tuesday about this because the way it seems is it seems like these hormones, they, like you said, they work with the sympathetic nervous system and they're speeding it up. That would cause the dilation.
well, I'm just
Hmm.
gonna make note of it and ask if that has anything to do with it. But that's the only thing I can find that it talks anywhere about blood flow.
Yeah. Okay. Last question.
Okay.
Explain the function of prostaglandins and discuss how medications such as ASA and IB may inhibit their actions.
Huh, what is a prostaglandin? What is that?
Oh, I remember this because it was like don't overdose on anti-inflammatories.
Aspirin and what's IB?
ASA is aspirin and IB I think is ibuprofen.
Oh, okay.
I think that would be an NSAID. Oh my God, is somebody calling you?
Hello? You there? Can you hear me?
Okay. For that, it says the prostaglandins are hormones derived from a fatty acid called arachidonic acid. The prostaglandins are produced by many tissues and generally act near their site of secretion. The prostaglandins play an important role in the regulation of smooth muscle contraction and the inflammatory response. Prostaglandins are also thought to increase the sensitivity of nerve endings to pain. Drugs such as aspirin and ibuprofen block the synthesis of prostaglandins and are therefore useful in relieving pain and inflammation. Okay, so I think that's it for this lab. Margie, are you still there? Okay. I'll end it here.